Hey there everybody, this video is about using related rates and volume of things, especially volume of cones. It looks like I have two cone problems here. They're kind of neat and have lots of algebra to them. So let's see. This is our vertex down being filled with water. So we have a rate, right? To identify the water is being filled at a rate of 15 cubic feet per minute. Okay, so volume has a rate, right? The volume of the amount of water is 15 cubic feet per minute. So that's how fast water is going into your cone. There is initially 40 cubic feet of water in the cone to begin with. All right, so there's already water in here. And the tank is 20 feet tall. So that's the height of the tank, right? That's the maximum height of the tank. And the diameter is 15, so 7.5 for the radius. Because we need radius when we're talking about volume, not necessarily diameter. So the first part says, express the volume of the tank as a function of its height. Okay, so we've been doing this in some other videos and in the class, but let's start off with what we know. Volume of the tank. So our tank is a cone, so we're going to start with our cone volume. 1/3 pi radius squared times h is the volume of our cone. And it says as a function of height, so somehow I need to replace my r. Okay, and it turns out that when we're talking about a cone, there is always this ratio relationship between the radius and the height. Okay, so right as the water goes down, as the water decreases, the radius decreases proportionally, right? So if this were 10, if there was a height of 10, then the radius would be half, right? Because 10 is half of 20, so this radius would be half of 7.5, which is like 3.75, I believe. I'll have to check my calculator, but I think that's 3.75. So there's a proportion. As one part shrinks, as the height shrinks, the radius shrinks proportionally. So there's always this relationship between the radius and the height because it's a cone, right? And because these are right triangles, we can use the right triangle similarity theorem and say that these are two right triangles that are similar because they have the same 90-degree angle and the same vertex here. So these are similar triangles, so we can set up our proportion. Well, we write r over h is in proportion to 7.5, the radius of maximum, over 20, the height maximum. So we're using these values that come from your problem in order to set up your ratio. And this says as a function of height, so I need to solve for r over here. And I do that by multiplying by my denominator. So my radius is 7.5 times the height divided by 20. Okay, so this is a nice fraction. Now we're going to take this ratio, right, and we're going to put it back into here as just the radius. So the radius is 7.5h over 20. Okay, now I'm still needing to square that. Right, it's radius squared, and I'm timesing that by h, and I'm timesing it by pi, and I'm timesing it by 1/3. Okay, so here's where the tricky part comes in, is having to simplify this equation. So I have some stuff to do. I need to square 7.5, I need to square h, and I need to square 20. Okay, so I'm getting out my calculator. 7.5 squared is 56.25. H squared is, of course, just h squared, and 20 squared is 400. And I'm kind of squishing everything in here. But we still have the 1/3, we have the pi, and we have your h, right, this h afterwards here that I still need to think about. So now I can finally simplify all of this stuff. The volume is, I'm going to multiply all of these things together. 56.25 pi times h cubed, all divided by 3 times 4 is 1200. Right, now this isn't the most attractive formula, but this is 100% correct. For our situation with a 7.5 foot radius and a 12 foot height, This is the volume of that cone as a function of its height. Okay, so now let's go and answer our next question, what says, what is the depth of the water initially? Right, so the depth of the water is the same as the heights of the water, right? Height and depth are the same for water. So I know there is 40, that's the volume. The volume we're given is that there's 40 cubic feet, and I'm gonna set that equal to 56.25 pi h cubed divided by 1200. So let's solve this for h, okay? So your steps are get rid of your denominator. So we're gonna multiply both sides by 1200. All right, multiply by 1200. So let's see, calculator says 1200 times 40 is 48,000, 3 zeros, equals 56.25 pi h cubed. Okay, now I'm running out of space, but I'm going to divide by 56.25. That gives me 853 1/3. Right, it's got 0.3333 in your calculator. So now I'm going to divide both sides by pi. Okay, so this should be interesting. I'm down to 271 point something 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 6244 equals h cubed. And now I'm going to take the third root of that number in order to figure out what the height is. So we hit the control caret button on your TI Inspire calculator, right? It's the caret button, it's this button right here. You hit control and then that button, and that gives you the third root. So you put a little 3 out there, and then you put 271.6244. And my initial height of that water with 40 cubic feet is 6.476 feet. So that's how deep the water is to begin with. With 40 cubic feet of water, the height or the depth of the water is 6.476 feet. Right, so just algebra solving that for h. Now, how much water is in the tank after 10 minutes? So we have water going in at a rate of 15 cubic feet per minute. So the volume of water is 15 for every minute, so 15 times m, m stands for minutes, plus the initial 40 that's already in there. Okay, so don't forget about that beginning value of 40 cubic feet of water. So I'm going to take my 10 and I'm going to substitute in for m. So 15 times 10 is 150. 150 plus 40 is 190 cubic feet of water. Okay, so that's where my rate comes in, right? The rate allows us to know how much water has been added to our tank in 10 minutes if the rate is 15 cubic feet per minute. And then your 40, that's already there. So what is the depth of the water after 10 minutes? Well, now we're going back to our formula from part A. We know that the volume is now 190, and we have to set it equal to our formula, 56.25 pi h cubed all over 1200. And we're going to do the same thing in step number B that we did. We're going to multiply both sides by 1200. So 190 times 1200, that's 228,000. Okay, I'm going to divide by 56.25. Okay, that's 4053 1/3. Okay, equals pi h cubed. Now I'm going to divide by pi. Okay, divide that by pi. And I get 1290 and change. 0.216 equals h cubed. And my last step algebraically is to take the cube root. So we take the cube root of that answer. The cube root of 1290 and change is 10.88. 886, so basically 890, but 10.886 feet is the depth of the water after 10 minutes. Okay, it started off at 6.5 feet, and now it's at 10.9 feet. Okay? And your last question, how long until the tank is completely full? So we need to calculate the volume of a full tank. Okay, so if that's true, if the tank is full, that means there is a height of 20. Okay, so we could go back to the normal formula, 1/3 pi r squared h, if you wanted to, right? We know the radius is 7.5, we know the height is 20, but I've been using this formula for a while, so I'll just use this one. It has a height of 20. So 56.25 times pi times 20 cubed divided by 1200 has a volume of 1178 and change. Okay, 0.09, basically 097, okay, is the volume for a completely full tank. Now I'm gonna set that equal to my formula from part C, right? So this is my volume rate formula, 15 every minute plus your initial 40, right? We have to understand that there's initially 40 in there, and that doesn't count against our time. Okay, so we're only really trying to fill it up 1138. Okay, so if we divide 1138 and change, 1138.097, divide that by 15, and I get 75.87 minutes. Okay, it would take more than an hour and 15 minutes in order to fill that tank up completely at 15 cubic feet per minute. Okay, so when we talk about when, we want to go back to our rate problem, right? And C tells you the rate, the 15 minutes, 15 cubic feet per minute, plus your initial 40 that we have in there. Okay, all right, excellent job. When salt is poured onto a flat surface, it naturally wants to form a cone, okay, or sand. Those things are pretty neat. The radius of the cone is 3 times the height. The radius is 3 times the height. Salt is being poured out at a rate. So here's the rate of salt, and there's initially a 0 on the ground to begin with, right? We don't have any salt there on the table. We are pouring salt onto a flat surface. Express the volume of the salt as a function of its radius. Okay, so if the radius, that means, let's go back to our formula. Sorry, back to the formula. Volume is 1/3 pi r squared h. So as a function of its radius means I need to get rid of my height. So I'll come back to this relationship. The radius is 3 times the height, but I have to solve it for h. So if the radius is 3 times the height, that means the height is 1/3 of the radius. So I'm going to plug that into my formula. Instead of h, I now have r divided by 3. I'm replacing h with r over 3. So this should simplify to, let's see, denominator times denominator, so it's a 9 in my denominator, and I just have pi r cubed in my numerator. Okay, so a pretty simple formula right there, pi r cubed. How much salt has been poured out after 20 seconds? Well, that's 0.65, right? That's my rate, times 20 seconds. My calculator says 0.65 times 20 is 13. So it has been 13 cubic centimeters of salt has been poured out after 20 seconds. So what's the radius of the cone after 20 seconds? Well, I'm going to take my volume of 13 and set it equal to my formula for volume as a function of radius. And I'm going to solve this equation for r. So once again, multiply by your denominator to begin with. Right? That's step number 1, is to multiply by your denominator. 9 times 13 is 117 equals pi r cubed. So divide by pi. Right, we want to get r by itself. 37 and change, so 37.242 in my calculator. I'll leave all those digits. And the last step is to take the cube root. So once again, control caret if you have a TI Inspire. That's how you get the third root button. And I have a radius of 3.339 centimeters is the radius. 3.339 centimeters is the radius. Okay, and the last set, what is the height of the cone? Well, the height is the radius divided by 3. Okay, and that's what we found up there. The height is the radius divided by 3. So 3.339 divided by 3 is 1.113. So not very many centimeters, only after 20 seconds. So the height is 1.113 when the radius is 3.339. Okay, so it's a matter of, right, simplifying, replacing your R if you need to replace R, and replacing your H if you need to replace H. Okay, so these are volumes related rates. Thank you and goodbye.